earlier in the week, the robotics team, in collaboration with with the Canadian Space Agency, which obviously supplied the station's robotics, the major components of the robotics system of the International Space Station, along with investigators at NASA's Goddard Space Flight Center, participated all week in the robotic refueling demonstration. And we have an opportunity to talk to Ben Reed, who's the Deputy Project Manager for the Satellite Servicing Capabilities Office at NASA's Goddard Space Flight Center outside Greenbelt, Maryland. Ben, are you there?
I am here, yes.
Hey, well, I really appreciate you stopping by. I know you've had probably one of the busier weeks, maybe not just weeks, but couple of weeks in preparing for this and then leading up to all this activity this week. First off, I have to ask, how's your weather up there? I heard there was some storms headed your way.
Right now it is cold. We've had below freezing for 3 or 4 days, but presently no precip, so not too bad.
Well, yeah, down here it's probably about 70 and sunny, but that's okay. Not inside here in Mission Control, and probably not inside where you are. Shirt sleeve environment. Lay the groundwork for us in what y'all did each day this week. I know you had a little bit of a glitch getting started. Obviously, you can talk about that if you want at the outset, but lay the groundwork for us of what y'all did this week and how it ended this morning earlier.
Well, we've had an incredibly successful week. We could not be more pleased with the cooperation of the folks, the robo-flyers down at Mission Control, the Canadian Space Agency, our good friends Pro at Marshall Space Flight Center, as well as my team here at Goddard, working together on this robotics refueling mission, which I don't want to sound overly dramatic, but it is, or it might be, only history will tell, the start of what could be a revolution or a new era in how satellites are built and flown in space. And so what do I mean by that? Well, what we're doing on Space Station with the robotics refueling mission, what we did this past week was to demonstrate the present-day technology is able to access, take apart, disassemble the fittings, the lock wire, these small caps, this crushable seal that is, half the diameter of a penny, with present-day technology, with the robot, the Dexter, special-purpose Dexter manipulator up on Space Station, is able to undo these triple seals that are on more than 900 satellites presently operating in space. And what that means is that fleet owners and operators, people who run these satellites, perhaps could have options in the future. The present paradigm is to operate a satellite when it has an anomaly or when it runs out of fuel. You decommission it, you build a replacement, assuming you have the funds to do so. What satellite servicing brings to the table is the possibility that one could go up with a robotic spacecraft and give it more fuel, fix a solar array, perform some sort of a servicing function, a repair, a refueling, a relocation to allow that satellite to continue its operations longer. And the unique capabilities of the space station with Dexter up there, with the ELC platform where you can mount technology demonstration payloads like this, is simply fantastic. It allows us to quickly advance technologies, prove that the technologies work in orbit for much, much cheaper than if I had to do this on my own, as it were, without the help of the great capabilities of the International Space Station.
Well, I was going to ask you about that because, that's one thing that people maybe tend to overlook is, we think about the station as a science laboratory because of what we're doing inside, but the station is kind of like the shuttle was. It's like a test bed, and isn't this a perfect opportunity to demonstrate that the station can be used for this type of work that, 10 years from now, maybe sooner, we're doing the kind of thing that you guys are studying?
Absolutely, I couldn't agree more. I am Space Station's biggest fan. Working with the Payload's office there in Houston to get a ride to orbit, and then a nice, safe installation onto the outside of the station, be able to conduct your experiment, and then when the experiment is done, we get to use that technology and go to the next step. Space Station simply turns its attention, as you said, to alpha magnetic spectrometer, right? Yesterday you're working on my thing. Today you're working on the next one. I mean, it's and I realize lots and lots of things are happening concurrently, but it really is an incredible in-orbit infrastructure that allows rapid technology development and demonstration. And I couldn't be more pleased to take advantage of it. And I know my potential future clients are also pleased that they can point to this and say, hey, look, this is it's been demonstrated in space. My anxiety can be eased that much more because I've seen it actually happen in zero-G. I don't have to take somebody's word for it that a ground demonstration will work the same in orbit.
So, so lay out how the week kind of progressed for you guys, and where you started and where you ended, because I think, didn't you end with an actual simulated refueling of a satellite?
Yes. So we started middle of last week. We had a couple of days of operations where we used Dexter to pick up our wire cutter tool. We cut lock wire, and this is small wire. This wire is 20 thousandths of an inch. So not large wire by any stretch, but we were able to precisely snag that wire, use our custom-built wire cutter tool to snip the wire. We then put that tool on the back burner, picked up our multifunction tool with its special adapter that's been designed to handle a tertiary cap, which is about the size, a little bit smaller than a coffee mug. We securely fastened ourselves over that tertiary cap, unscrewed it, and safely stowed it to the top of our module. Still holding the wire cutter tool, we then moved in and cut two more wires equally small. Put those two tools away, the wire cutter tool and the multifunction tool away. We then used our safety cap tool to remove the next cap that was nested under the tertiary cap. And this is completely different form factor from the first cap, so we had to have a different tool to do it. We removed that cap, safely stowed it, and then last night was the final act. That's where we picked up our nozzle tool. We threaded onto the exposed fill and drain valve threads, which any roboticist will tell you is not easy to do. Threading on is tricky business. But we, the joint team, expertly threaded on. We then opened up a series of valves, reservoirs, pumps, turned them on through our friends down at Marshall, and we pumped 1.3 liters of liquid ethanol across this robotically mated interface with no leakage. Very successful. We were very happy. We then separated and left behind we withdrew the tool, leaving behind a quick disconnect fitting. And in the process of doing so, we expected it, we predicted it. There was a very small amount of ethanol that was trapped between the two seals, and we have a very cool video of that ethanol spraying out in the vacuum of space and then rapidly evaporating. And that will be posted on our website, and I'm sure YouTube before the day is out. So I encourage people to go look for that. And then we put that tool away, and we concluded roughly around midnight Eastern yesterday.
You know, you mentioned about the residual ethanol, and that's one of the things that we talked about, when we do spacewalks, and how critical it is to try to make sure that we, connections, like you mentioned, are very precise with cabling and things like that. And I guess this is just another way of showing, because spacewalks are very valuable, obviously, and they're as risky as just about any other activity we do in space. So the robotic marriage of crew members outside doing tasks and the robotics of doing tasks this is just another demonstration of that. But what you're talking about doing And I wanted to ask you about, what are the next steps now, but and what you're doing is talking about servicing satellites that, astronauts right now cannot get to. And that's a much more expensive process anyway, probably in the long run, right?
That's exactly right. That's exactly right. I think a good analogy that many of our listeners and viewers will be able to associate with is deep water oil drilling. So we do send divers down quite deep to help assemble and maintain these rigs, but when we need to go really deep, that's when we send the remote-operated vehicles, and only the ROVs go really, really deep, where it's more dangerous, where humans cannot get to yet. Well, robotics in orbit, I think, is very, very similar. We have done countless amazing feats with humans and robots working in low Earth orbit. Hubble Space Telescope, the Solar Max Repair mission, all the assembly and maintenance of space station are fantastic examples of what we can do as an agency. But to go further out, presently, today, in 2013, say to geosynchronous orbit, is prohibitive right now with present-day technologies for our astronaut corps, and that is the area where robotics can step in. So we still have human in the loop. It's still humans and robots working together, only the humans are on the ground with the joysticks, with the procedures, making those intelligent decisions that only humans can do, and we use robots where it presently is inaccessible by astronauts. So in my world, it is never either or. It's just a matter of how do we adjust the paradigm for that particular environment with humans and robots working cooperatively together.
I wanted to take a brief moment just to remind everybody, we're talking with Ben Reed, who's the Deputy Project Manager for the Satellite Servicing Capabilities Office up at Goddard Space Flight Center, NASA's facility outside Washington, D.C. and Greenbelt. And Ben, you're setting me up perfectly for my questions because you mentioned Hubble, and Hubble Space Telescope from the very beginning was designed to be serviced in space. We knew that it was going to be launched, and over periods of time we were going to change out the science experiments as technology advanced and cameras were advanced, and that's what we did on 5 different servicing missions, and it was designed that way. We still, even then, when astronauts were working on Hubble, we ran into some issues here and there and learned from them. We designed tools specifically for Hubble servicing. But these communication satellites and other satellites that are out as far as GEO, obviously they weren't designed to ever be touched again. And what you're doing is demonstrating this capability on those types of satellites. So do we learn from this in the future design of satellites, say, okay, well, we're learning how to refuel these robotically, so you might want to change your design. So you mentioned the satellite builders and are taking great interest in what you're doing. Can you describe a little bit about what the future holds for maybe satellite design, that type of thing?
Well, I got to say, you're setting me up perfectly for my answers. So we have been approached by various stakeholders in the geosatellite community with exactly that type of question. Ben, if servicing in GEO is going to happen by somebody in the near future, and by near I mean 5, 6, 7 years, what can I do as an owner or as an insurance provider or as a satellite manufacturer to make my asset, my very expensive asset in that orbit, more amenable to servicing? And so because of the work we've been doing with RRM, and other aspects of our ground technology campaign, we put together a list of specific actions, not generalities like make your connections standard. They need specifics. So we put together a list of specific actions that stakeholders in the geosatellite community could do now with satellites that are on the shop floor being built presently to make themselves more amenable to servicing. And being NASA, I am required by law to have an acronym for that list, and that list is called COSA, C-O-S-A, or Cooperative Servicing Aids. And we issued this letter, this COSA letter, to the geo stakeholder community. It's out on the internet, and it's not to mandate to anyone what they need to do, but rather to open a discussion with the various members of that community as to what makes sense. I don't think anybody's going to attach a 20-kilogram grapple fixture to a geocommunications bird next week. By no stretch of the imagination is that what is being suggested, but rather, maybe a decal, maybe put a bumper sticker or two on the aft end that would aid the cameras and the lasers that are going to help with guiding two vehicles together. Something that is low mass, low impact that could be done in the near term.
Yeah,
so
exactly.
that's a discussion that is being begun now, and I'm sure, well, I certainly hope will continue for years to come.
Yeah, exactly. One last thing before I let you go. What's next for you guys? What do you see coming up? Further work, obviously, with RRM on orbit, and what do you see coming up next?
So in our near future, later this year, we are going to launch 2 additional task boards. So I haven't mentioned that phrase yet, task board, but we designed the RRM module to be modular, to be serviceable. So many of our legacy satellite interfaces that are on RRM are on task boards that are easily removable by the special purpose dexterous manipulator. So later this year, we will launch 2 additional task boards, and they will be taken out through the GEM airlock, through the Japanese Experiment Module external airlock, and then robotically swap out the ones that are on RRM now with the new ones, and that will give us a fresh set of tasks that we would like to demonstrate, to practice on, to learn from on orbit. So RRM is not over. We have additional tasks yet still on it to be done this year that are presently up there, and then these new task boards will follow immediately in the summer or the early fall. So we've got a busy agenda yet ahead of us.
Well, that's great, and I know it's a very slow process, but you have to start somewhere, and this has been, as you said, it's been an amazing week. It's been fun to watch, from here in the flight control room, and good luck with all the future stuff, with everything you guys are planning, and thanks again for joining us here in Mission Control, Ben.
It's been my pleasure. Thank you.
Okay, that's Ben Reed. He's the Deputy Project Manager for the Satellite Service and Capabilities Office at NASA's Goddard Space Flight Center, one of the field centers that support the agency. It's in Greenbelt, Maryland, just north of Washington, D.C., just outside the Beltway. And as you heard Ben say, the plans are for future task boards to be launched to the International Space Station, so I'm sure we're going to hear a lot more about robotic refueling in the future, using the space station as a test bed for those activities.